Alright, we're going to do 7.2.3 geometric sequences. This is one of those videos that I pre-recorded and my microphone wasn't working. So I'm going to be just talking over the video. So if things are kind of off, I apologize. So geometric sequences, we're going to have the recursive formula, which is a to the n equals r times a to the n minus 1. And the explicit formula as written. Recursive is capable of giving you the next term. You're given a term, you can always find the next one with the recursive. Explicit will allow you to find any term in the sequence. A1, that subscript 1, just means first term. If it was A7, it would mean seventh term, so whatever that subscript is. R is a common ratio. I believe the previous section was arithmetic sequences and you dealt with common differences. Right, you're adding and subtracting. This is going to be common ratio, which is going to be multiplication and division. So it's going to be the same concept you guys did last section, but with a little bit more multiplication and division. So we'll see if we're jumping in now. So find the common ratio. So what we're going to do is I need to take the second term in the sequence. So I'm labeling my terms 1, 2, 3, and 4. I need to take my second term and divide it by my first term. And I'm going to take my third term, divide it by my second. Then I'm going to take my fourth term and divide it by my third. And what we see is we have a common ratio of 3. Alright, so it's always the previous term divided by the, it's the next term divided by the previous term. Do the same thing for number 2. It's going to be second divided by 1, the second divided by the first one, third one divided by the second one. And then that's going to give us our common ratio, which is similar to what we did with common difference in the arithmetic sequence, right? We took the second term and subtracted the first term. Third term and subtracted the second term. Now we're just using division instead. So I'll probably use a calculator to figure this out because I'm not that smart. Small brain. 25 over 125 be 1/5. So I have a common ratio. Cool. Going to question 3. Is this an arithmetic sequence or a geometric sequence? Remember, arithmetic is when you add or subtract between terms. Geometric is when you're multiplying or dividing between terms. So I have a plus 5, plus 5, plus 5, plus 5. So I'm adding arithmetic, automatic. Alright, so the next question is telling us it's a geometric sequence. They want the recursive formula. So what do we need for the recursive formula? Well, all we need is the common ratio. That's it. That's the only part we actually need to plug in for and find is the common ratio. So there's my formula. And now I just need to find what the common ratio is. And how do I do that? Just like I did in questions 1 and 2. I divide second term by the first term, third by the second, fourth by the third, fifth by the fourth, sixth by the fifth, etc. And I found a common ratio of 1/2, and then I just plug that value in. That's it. That's a recursive formula. Nice and simple. Alright, now we want the explicit formula. Alright, so now the explicit formula, you need a little bit more. For the explicit formula, you need the first term and the common ratio. So the only difference is I need to add the first term as well. So I need the common ratio for both recursive and explicit. But for the explicit also needs the first term. Well, the first term's easy. It's 7, they tell us. And then the common ratio is easy too because we know how to calculate it. Divide second one by the first one, third one by the second one, fourth one by the third one, fifth one by the fourth one, sixth one by the fifth one, seventh one by the sixth one, eighth one by the seventh one, ninth one by the eighth one. I can go on forever. So we're doing that. I'm getting a common ratio of 4. I have a first term of 7, and I'm just going to plug it right on into that fancy-dancy formula that we talked about at the beginning of this video. We're not trying to trick, we're not trying to make it difficult, we're trying to make it nice and easy on you. And I'm probably talking about some other nonsense. There we go. So we're going to plug in. I know what my first term is. It's 7, so it's going to be 7. I know what my common ratio is. It's 4. And I'm just going to put my n minus 1 in there. Boom. And boom goes the dynamite. Alright, so now question 6. They're telling me that I have a geometric sequence and they give me the explicit formula. Now, I know that the explicit formula will give me the first term of a sequence as well as the common ratio. Those are the two things that I can get from explicit formula, right? So that tells me that my first term is -2 and then my common ratio is 3. All right, so that's what the explicit formula told me. Now, that's not what they asked, but I wanted you, as soon as I saw explicit, I knew what I would get from that formula. Now, for us to find the fourth term, remember, these are all formulas a to the nth power, where nth represents whatever term we want. I just plug 4 in for n, and I'll calculate. So we'll see if I actually do the full -54 maybe. I must have been tired and I couldn't do this math on my own. There we go. See, it's amazing. Sometimes you can do quick mental math, sometimes you can't. So I'm over here rewatching myself, and that took a little bit longer than it needed to be. Now what are we doing? See, this is why videos take so long, because I'm probably just talking about a bunch of nonsense. All right, the number of plays in our tennis tournament is reduced by half, right? So reduced by half is telling me a ratio right there. After every round, and in round 1 there are 256 players. So they tell us right away that the first term is 256, and then in round 2 there's 128 because it's getting in half. So they want the explicit formula. For the explicit formula, I need the first term in the common ratio. Well, they told me the first term was 256, and they told me my common ratio was 1/2. I just plug it into that fancy dancy formula we got at the top of this video. Question 8 tells me how many players compete in round 7. Well, if I want to find that out, I just plug 7 in for n. You plug 7 in for n, and it's going to calculate the answer for us. Now I'm probably going over to Desmos to type this in and solve this. Just 1/2 to the 6th power, I do not know. It's 4. So in the 7th round, there's 4 people. That makes sense. All right. Where are we going from here? Cool. Geometric sequence has the explicit formula. So it has an explicit formula that tells me I now officially know what the first term is and what the common ratio is. Right? If they give me the explicit formula, I know what the first term is and the common ratio. Excellent. Now they want us to find the recursive formula. Well, I know the recursive formula only needs the common ratio. Right? So explicit formula needs first term and common ratio. Recursive is just common ratio. So I can then identify the information I know, and then I can plug it into the recursive formula, which is just the -2 is the only piece I need. Boom. Now, question 10 goes the opposite. It gives me the recursive formula, which tells me the common ratio. So the recursive formula tells me the common ratio. And they want to tell me what the explicit formula is. Well, the explicit formula needs first term and common ratio. So I can get the common ratio from the recursive formula, but they would have to tell me what the first term of the sequence is. And they do. The first term is 2, so I can use that information. And then the recursive formula tells me that the common ratio is -3. Is it negative, so I use parentheses. Trying to follow good habits.